So on last night's homework, this is a nice segue because you read the words the unit circle a bunch of times, and I have not even mentioned that. So what the unit circle is it is a kind of a rotational diagram. So if I take my little bobby pin here, and you kind of wrapped around that terminal ray to make a circle, you would assume in the unit circle that the length of that radius is 1. So all it is it's a circle where we know the radius is 1, which means we know if they use the words the unit circle, we know that the terminal ray has a length of 1, which means your hypotenuse, whenever you drop a right triangle, will always be 1. So unit circle, you can write radius equals 1. You can write the hypotenuse equals 1. Same thing. Okay? So that's what the unit circle is. Now, this whole terminal ray endpoints here, this is something I will create a flashcard on. That if you know the points at the end of a terminal ray, the x-coordinate is whatever the radius times cosine value is. And the y-coordinate is whatever the radius times the sine coordinate is. So I remember the sine is the y because they kind of rhyme. You know what I mean? Okay, it's a stretch, but, or you could just go, you know that the x-coordinate is cosine and the y-coordinate is sine, because you'll get confused how to keep them straight. Cosine then sine is just alphabetical order, x-coordinate then y-coordinate. So find a way to remember that, and that's the point at the end of a terminal ray. So we'll just jump through these examples. A circle centered at the origin has a radius of r. The terminal side of an angle intercepts the circle in quadrant 1. So let's just do a circle centered at the origin. And the terminal side of an angle, there's my terminal side of an angle in quadrant 1, intercepts the circle at the point xy. Okay? So all the, like, find the values of x and y in terms of r and theta. This is really the definition. The x-coordinate is r cosine theta, and the y-coordinate is r sine theta. So whatever the radius of that circle is, times the cosine of whatever angle theta this is, that would give you your x-coordinate. And if you wanted your y-coordinate, you would take the radius of this circle and multiply it by the sine of that angle. So just a rule you have to memorize. Okie doke. In the next one, it says if an angle of 150 is drawn. Well, that's about what quadrant, Lucas B? 150. Quadrant 2. Probably right around there. Okay. It says find the coordinates that lie on the unit circle. So unit circle means this length is 1, right? And they want the coordinates. They want the x-coordinate, which is r cosine theta, and they want the y-coordinate, which is r sine theta. We know that our radius is 1 because we're in the unit circle, right? So 1 times. And we want the cosine of 150, comma, and for our y-coordinate, we want the radius of 1 times the sine of 150. And then we just have to figure those out. The cosine of 150, and this is where a couple days ago we have to think. If we're doing the cosine of 150, what quadrant are we in? 2, so is cosine positive or negative? Okay, so we know it's a negative. We can ignore the 1, right? Agreed? 1 times, who cares? And the reference angle is what? Yep, it's 30. 150 to 180 is 30. So what is the cosine of 30? Nope. That's the sine of 30. Radical 3 over 2. Good. Start to memorize those. Your calculator's not going to tell you that. Your calculator's going to give you a crazy decimal. And then for the y coordinate, the sine of 150, since we're still in quadrant 2, is sine positive or negative? Positive. And the sine of 150 still has a reference angle of 30. What's the sine of 30? A half. So still continue to learn those values. You'll have quizzes, multiple of them, flashcard quizzes on those next week. So that's your answer. You're done. Just to like round out your perspective, if I were to make a right triangle, this length would be negative root 3 over 2, I now know. And this length would be 1/2. And if you were to do the Pythagorean theorem with those, it would work out. Negative root 3 over 2 squared plus 1/2 squared would give us 1 squared. If you just, all these things will come together. But there are the coordinates at the end of that. Okay? Any questions? An angle of 5 pi over 3. What quadrant, Vince, are we in? Say it again. Nope. Natalie? Nope. Vince. If this is 0 and our denominator is 3, how should I be labeling this? 3 pi over 3, and then a full circle I should be labeling 6 pi over 3. So can you guess again where 5 pi over 3 is? Fourth quadrant. Got it? So fourth quadrant goes all the way around, and you would drop your right triangle. But at the end of the day, find the coordinate pair. So the coordinate pair is going to be our cosine theta for your x, our sine theta for your y. They're telling you radius of 5. So that's 5 times the cosine of 5 pi over 3, which we're going to have to think about, and 5 times the sine of 5 pi over 3, which we're going to have to think about. So, for the cosine, 5 times, we do have to keep that here. Is the cosine positive or negative? Chloe? Positive, because we're all students take calculus. The cosine is positive. What is the reference angle, Kate? Say it again. 1/3 pi, pi over 3, right? This is one of those where 5 pi over 3, it's pi over 3 family. Reference angle is pi over 3. So what is the cosine of pi over 3? Pi over 3 is like a 60-degree angle. Yes, 1/2, very good. Again, there's nothing for me to explain there. You just have to know your values. And you, obviously, most of you have not memorized those yet, nor do I expect you to, but by Monday, have those much better. And then this one is 5 times. And is sine positive or negative, Eric? Say it again. Negative. Fourth quadrant, it's negative. And then the sine of the reference angle, pi over 3. What's the sine of pi over 3? In other words, what's the sine of 60? Root 3 over 2. Yep, good. Root 3 over 2. So when I clean this up, 5 times 1/2, you can just write 5/2. And 5 times negative root 3 over 2 is going to be negative 5 root 3 over 2. And there's your coordinates at the end of that terminal ray. Okay? So up until this point, and I'm only going to close this, I'm not closing it up for everybody, but for the people that have to leave, yeah. Up until this point, you've been given the coordinates at the end of the terminal ray, which kind of create your triangle for you. This is, you're not given that, okay? You actually, have to, yeah, sure. So those of you who have to go, grab a homework on your way out. If Jason hasn't already given one to you, they're right here. Everybody else, we're going to continue on the back. What's our back look like? Good, goodbye. Fun, where are you going? Oh. Say hi to the airplanes. Oh, you did? Okay. Goodbye. Oh, this is nice. Not that I don't like them, but this is nice and cozy. Just a few of us. 26 down to 15. All right. All of the points on the unit circle must satisfy this equation. Okay, that should make sense because, and I say why do you think, but I'm going to show you. If you're a point on the unit circle, any point x, y, so I'm going to make this x and this y. X, y. That puts me on the unit circle. And because I'm on the unit circle, Owen, how long is this? 1. So do you see why every point on a unit circle specifically, not on all these circles, but if it's a unit circle, has to satisfy x squared plus y squared equals 1? Right? So if you're given a point, you can figure out if it's on the unit circle just by doing x squared plus y squared and seeing if it gives you 1. If you know that shortcut. If you don't, I'll be honest, you can just go negative root 3 over 2, positive a half. You can find your own hypotenuse by doing a squared plus b squared equals c squared. And if it's 1, then yes, you're on the unit circle. If it's not, then you're not. Pretty much that's the same thing twice. So if I do x squared, that's negative root 3 over 2 squared, plus y squared, 1/2 squared, I'm going to try to figure out what the hypotenuse is. Is my hypotenuse 1 or not? Now, this one's actually a little bit tricky. It says verify that this is true. So I guess technically I should be verifying that this equals 1. It's more of a proof. When they say verify, it's more of a proof. I just would caution you, when you square a fraction, you have to square the numerator and the denominator, yes? When you square a negative, what do you get? A positive. When you square radical 3, what do you get? 3. And when you square 2, what do you get? Okay, so we have to square all those parts. Plus, this one just squaring the fraction. When you square 1, you get 1. When you square 2, you get 4. And can we confirm that 3/4 plus 1/4 is 4/4, which is 1 equals 1? Proven. Now, here's an extension type of question that we will get to, but let's do it now. If this coordinate equals r cosine theta, and we know our r is 1, right? Because we're on the unit circle. Negative root 3 over 2 equals 1 times cosine theta. So what is theta? You're using your table values, but you're using it sort of backwards. Because you know the value. So what's the reference angle? The cosine of 30 degrees is root 3 over 2, correct. But we know that this isn't a 30-degree angle because that would be in quadrant 1. We just know that the reference angle is 30 degrees, right? And so if the reference angle is 30 degrees, what is actually the measure of theta? 150. Does that make sense? 180, backing it up 30 degrees would put you at 150. They didn't ask that, but based on the fact that you know the point and you know what that equals, you can figure that out. And so just, I mean, not that the angle is going to change, but just to clarify on the y coordinate, 1/2 equals r sine theta. And we know r is 1, so 1/2 equals sine theta. So we know theta is 30, right? The sine of 30. But because we're in quadrant 2, it's really more that the reference angle is 30, which leads us to 150 again. Okie doke? Any questions? All right. Let's see what we got here. Go ahead, Jack B. Read that for me. Read it slowly, though, because I do not ever recommend reading math fast. It's not a novel. It is like heavy, thick material. It should take you 10 minutes to read a paragraph. No, I don't. Stop. A circle centered at the origin, we see that, has a radius of 10. So we know that no matter what one of these we end up working with, we're going to label it 10. Okay, keep going. Okay, so now what am I going to do? What am I going to draw? Very good. Draw a terminal line. I don't care where you draw it, in quadrant 2. Label it. What? 10. And what's this point C? Where's point C? On the circle, right where that intersects the circle. Beautiful. I'm not even going to read the rest of the question. I'm guessing that I should, just to get perspective. I always drop a right triangle. I don't know if we'll need that or not, but lightly drop a right triangle. Good. Got it. Get it? Good. Okay, Jack B, we're ready for you. Oh, okay. So if the y coordinate of that point is 8, what can I label? Yeah, what's 8? The leg, this leg. If this would give you the x coordinate of the point, negative something, and this would give you the y coordinate of the point, 8. So these details and ways of labeling a right triangle are very lost in a paragraph, but you have to read with a critical eye and sift through all that. And now they want to know what's the cosine. And cosine is adjacent over hypotenuse. Let me start here. Let's pretend you know nothing other than that we're in quadrant 2. What is cosine in quadrant 2 supposed to be, positive or negative? Negative. So I'm immediately done with those. Even if I know nothing else, I can use my quadrant stuff to my benefit. But we shouldn't be too far off because I think we're all pretty okay with quadratic, with the a squared plus b squared equals c squared. So what's the length of that leg? Yeah. Perfect. Thank you. You too. So what is it? Well, this is going to be -6, right? 6, 8, 10 is in the 3, 4, 5 family. If you're not fluent with those 3, 4, 5 things, just x squared plus 8 squared equals 10 squared, you will get -6. Well, you'll get plus or minus 6, and you need to know to choose the -6. So now when they ask for the cosine, adjacent over hypotenuse, -6/10, -3/5. Okay? It's tricky because a lot of that is done mentally. There's not as much written work in trig, in certain parts of trig. But there's drawings, and when I see what you draw and how you kind of label things, I know whether or not you understand it. You're certainly not going to just get the answer without doing a drawing and so forth. But there are things like completing the triangle with a -6 that I do know a lot of you can fill that in your head. All right, let's draw a rotation diagram for theta equals 225. Faye, what quadrant is this in? Very good. So here's 180, 225 is going to be right around there. What's my reference angle? Well, maybe that doesn't matter based on what they're asking. Determine its ordered pair that lies on the unit circle. So r equals 1. So your x coordinate is r cosine theta. Your y coordinate is r sine theta. So the ones don't really matter. It's 1 times the cosine of 225 and 1 times the sine of 225. This is just really what we've been doing, right? So cosine, positive or negative? Negative, because we're in the third quadrant. What is the reference angle? 45. So what is the cosine of 45? Very good, Corey. And then what is the sine, positive or negative? Negative. And the reference angle still is 45. That's not changing. The sine of 45 is also root 2 over 2. So does it make sense to you why you would have a negative coordinate followed by another negative coordinate? Okay? It's easy at times to forget a negative. But if you just check that at the end, does that location of a negative coordinate and a negative coordinate make sense? Absolutely. You're in the third quadrant, right? Both coordinates should be negative. Yes? Last one. 3 pi over 2. Where's that, Lucas B? Say it again. Well, not quite. How would you label this one if the denominator is 2? 2 pi over 2. So how would you label the halfway point? 1 pi over 2. So you have 0, 1 pi over 2, 2 pi over 2. This is actually 3 pi over 2, right? So your terminal ray is not in a quadrant at all. Got it? We're on the unit circle. So r is 1 again. So r cosine theta, r sine theta. 1 times the cosine of 3 pi over 2, and 1 times the sine of 3 pi over 2. Remember what I did yesterday. Your sines are zeros on the x-axis and 1 and negative 1 on the y-axis. So what is the sine of 3 pi over 2? Negative 1. So that's negative 1. And your cosines are zeros on the y-axis and 1 and negative 1 on the x-axis. They're like flip-flopped. So what is the cosine, Jack B, of 270? 0. Or cosine of 3 pi over 2? 0. 0 times 1 is 0. Why could we and should we have been able to know that without doing any of this? Not even from the table. It's the unit circle. So when I swing this ray around, this is always 1 unit long. If it lands right on an axis, you're 1 unit down. You are at the coordinates 0, negative 1. Should make sense. All right, your regular homework assignment is coming around. Sarah, you got away with me not hearing your voice today. So did you, Alexa. You two guys get away with that. More so than, I think, you know why? I think you're right in my line. I can't see you. I have to change that. There you go. All right.